Chapter 9 is about solving an easier related problem. So let's look at our introductory problem of the week. A rare disease affects 1 in 1,000 people. A test for the disease is 95% accurate. That means that 95% of the people who actually have the disease test positive, and 95% of those who don't have the disease test negative. What percent of the people who test positive actually have the disease? So first of all, isn't the answer just 95%? Isn't that what the problem says? And secondly, is this really a solve an easier related problem technique type problem? And the answer to the first question is no, it's not just 95%. What's given is that 95% of the sick people test positive. But we're trying to figure out is what percentage of the people who test positive are actually sick. And there's a difference. And we'll see what that difference is as we work through the problem. As for the second question, well, I'm not quite so sure this fits into Chapter 9 all that easily. Maybe it's more breaking it up into subproblems. Maybe it's more application of a tree diagram looked at one way. But this is where we're doing it, and it's certainly related to those. We'll be solving a number of easier related problems. So we use a very typical technique of just making up a number, starting number. So let's just pretend we start with 100,000 people. And of those 100,000 people, we're going to ask how many are sick and how many of those test positive. And of the original 100,000 people, how many are not sick? And of those, how many test positive? Well, we can answer those questions. The given information tells us. If there's 100,000 people, then 100 of them are sick, because 1 in 1,000. So 1/1000th of 100,000 is 100. So 100 of those people are actually sick. And of those, 95 test positive, 95% of the 100. Of the 100,000 people, how many are not sick? Well, 99,900, all but 100 of them. And of those, 4,995 test positive. 95% test negative, so 5% of the 99,900 test positive. So this 4,995 represents the small percentage of the large number of healthy people who test positive. 5% of the 99,900 healthy people. So now we can put it all together. There were 5,090 people total who tested positive. 4,995 who were healthy and 95 who were sick. And of those who tested positive, only 1.87% actually have the disease. 95 out of the 5,090. It's kind of surprising. If it's a 95% accurate test, you think, okay, if you test positive, you're probably sick. But when it's a very rare disease, then the small number of false positives totally outweigh the number of true positives. So our final answer is about 1.9% of the people who test positive have the disease. And we can also look at this as a tree diagram problem. So we start here with the 100,000 people, break them up into 100 sick people, 99,900 healthy people, 95% of these test positive, 5% of these test positive. What I didn't do was draw in the rest of the people, the ones who test negative, which would have been further branches down each of these, but I didn't need them for the problem. So this is a problem which typically trips up very, very many people, and lots of people, including very educated people, have bad intuition about these things. But if it's a rare disease, then a small percentage of false positives will outweigh the true positives from the small percentage of people who have the disease.